Good morning. Today we are going to solve one problem that is from question paper, and that problem is related with axially loaded column and biaxial bending. Now, in this axially loaded column and biaxial bending, we have to again go for the clauses given in IS. So now you can see design a biaxial short column by limit state method. Material we have given, that is M20 and Fe 500 to carry ultimate load of 600 kilonewton. Load is ultimate and moments are also factored. Mu x is 60, mu y, sorry, 110, mu y 60, and the unsupported length is 3.6 meter. The column is fixed at both ends. And then show details of reinforcement in plan and sectional elevation. So now we have to assume the dimension. Let us, I will assume dimension as 250 by 350. Now 250 by 300 I have not considered because little bit more difference we are considering because we have 110 and 60 as moment. So I will consider 250 by 350. Now when I will go for this, I will check it if I will go PU upon FCK BD. Why I am going this, you will understand this. So PU upon FCK BD, if I will consider, then I have PU at 600 into 10 raised to 3 divided by, we have FCK 20, B we have 250 and D we have 350. And if I will calculate this value, then we have this as 250 into 350 and I got this value as 0.91. Now we are going to assume P by FCK. So P we will assume 2% and then FCK we have 20. And then from this we will get this value 0.1. So now graph we have given in examination question paper. So we have this one. So now if I will consider 0.9 and I am going to draw a line, horizontal line, then you can see we have this as 0.2, 0.4, 0.6, 0.8 and this is 1. So this P by FCK line we have 1. So now if we do not have intersection of this, then we cannot get value of mu upon FCK BD. And therefore I have to go for higher dimension of the column. And now I will consider in this higher dimension, that is 350 by 450. And by considering 350 by 450, we are going to solve the column. Now, if you want to go for this, then you have 1600 to the power 3 divided by 20 into 350 into 450. And we have PU upon FCK BD, that is 0.5. So PU upon FCK BD 0.5, and it will cut this line of 0.1. So we can have this line. And therefore it's okay. Means your value of PU upon FCK BD, it should be less than 0.8. So it will cut your P by FCK. Now you can see we should not be on higher side. If I will go 0.8, then I will get MU upon FCK BD very less value. And if that is less, then we will get MU x1 less. And then our value of MUX is 10110. If this value comes greater than 1, that is, then it is of no use. And therefore we have to go on lower side, and therefore we have to go for higher dimensions. And I will consider it as 350 by 450. So I have sufficient value, that is of mu upon FCK BD comes around 0.1. And now we will go with the example. I have solved this example by considering two values. I will go in next video with another values. So now we will go with the problem. Now we have this problem. We have given dimensions. So that I have mentioned over here, that is M25. In question paper, we have this as M20. So we have this as M20, actually not M25. Then 415, we have actually in question paper again, we have this as 500. So we will go this as 500. Then PU 1600, MUX 110, and MUY 60 kilonewton meter. So now short column, we have LEX upon D, that is L effective, I can say, and we have this value that is 0.65 into 3600, and it comes 195, and the same for B also 195. And now I will consider column dimension 350 by 450. Now why I will go for 350 by 450, that already I told you, and accordingly we are with these dimensions. Now we will start to solve it. So now we will assume D dash 50 millimeter. So now minimum moment, this criteria we have to check it so that we have to consider value of MUX and MUY. So this actually we are generally using this for biaxial. We need not require to go for uniaxial. We will go it for biaxial moment. So you can use, but value of MUY, MUX given, and whatever we are doing for any one, you can use it by uniaxial. So now E minimum X we can have unsupported length is given 3600 500, and D we have taken 450 upon 30, it comes 22.2. If it is greater than 20, we have to consider as it is. So E minimum Y, now instead of 450 we have 350, and that value comes 118.67, less than 20, so we have to take 20. And by using this E minimum X and E minimum Y, we have to find out MU minimum X, MU minimum Y. Both these values are less than the given values. So our given values will be MUX and MUY values. So now we know MUX value, we know MUY value. And then we have to go for MUX1, MUY1. Now these formulas are given in IS 456. And from that you have to go for these values. Then we will assume percentage of steel 2%. Why I have considered it as 2%? Because we have FCK 20. So I will get value of P by FCK, and that will be 2 upon 20. And this value comes 0.1. If you have FCK 25, then you can consider value of P, that is 2.5. Then you will get value 0.1. Because if you will consider 1.5, then you have to again go, that is interpolation between the two, and that will be again not accurate, I can say, because we cannot go with that values of the dots. Now first we will go bending about x-axis Fy. We have given actually not 415, it is 500 Newton per mm square. D dash we have 50 on all faces, that is given. So now we have 0.11 D dash by D and PU upon FCK BD, it comes 0.51. P by FCK already mentioned, we have 0.1. So we have to use the chart, that is D dash by D 0.1. And then D dash by D 0.1 and D dash by D 0.15. And for these two, we have to interpolate the values. Now, first we will consider for 0.1. So now you have to keep in mind PU upon FCK BD 0.51, and this is 0.1. So what we have to go, we have to draw a horizontal line from PU upon FCK BD, where it will cut your P by FCK curve, which is 0.1. And from that you have to draw a vertical line, which will cut your MUX, MU upon FCK BD square. That value you have to use to calculate value of MUX. Now you can see this, we have this will be 0.51, and then we have this value, this curve you can see, you have this curve as P upon FCK as 0.1, you have this value 0.1, and therefore I will draw a vertical line from here, and that will gives me value of MU upon FCK BD square, and that value for 0.1, we have this value as 0.1. This is d dash by d. And this value is mu upon fck bd square. Now we will go another graph which is for 0.15. Then again we have to draw a line from 0.51 and then it will again cut 0.1 curve and then we will plot vertical line and that is 0.1. So last value, if you will see it, I can say 0.11 because it is close to this, and here I will consider value 0.1. So what values? So for 0.1 I have 0.11 and for 0.15 I have value 0.1, and then I will interpolate it. Now that you know how to interpolate it, so we can have 0.11 minus, we have 0.11 minus 0.1 divided by 0.15 minus 0.1, and then we have to multiply it by 0.11 minus 0.1, and that value gives me 0.108. Knowing 0.108, we can calculate value of MUX1, and we will have this value of MUX1 will be 153.1 kilonewton meter. This value we have Newton millimeter, and MUX1 we will get 153.1 kilonewton meter. Now we have to go bending about y axis. So Fy again, that actually I have taken it wrong. So it is 500 Newton per mm square. Then we have steel on all faces. Now d dash by b. Now we have bisecting width 50 upon 350. So I got this value as 0.14. And Pu upon FCK BD remains same 0.5 when P by FCK is 0.1. Again we have to go for same chart, that is 0.1 and 0.15. So first we have from 0.51 and 0.1. So you can see we have this value, that is what value I have actually taken, 0.11. So again it will be close to 0.11. So I have taken this value again because we have all the same. Only curve we have 0.1. So this value comes 0.11. And this value we have again, that is 0.1. So likewise we have these values. So we have 0.11, 0.1, and we have to find 0.14. It comes 0.102. And from this, if we will calculate value of MU1, this value comes 112.46 kilonewton meter. And knowing these values, we are in position to find value of MUX upon MUX and MUY upon MUY1, that formula. Now first we will find PUZ, and we have PUZ 0.45 FCK, and this value we have ASC we have taken 2%, and therefore it is taken 0.02 AG. Sorry, this is ASC, and this value we have, that is only AC, area of concrete. So we have subtracted 0.002 from 1, so we will get it as 0.9 AG. And substituting this value AG I have taken common, that is 350 into 450. I got value of PUZ. Now knowing PUZ, knowing PU, I can find PU upon PUZ. I got PUZ 2570, from which I will get PU upon PUZ 0.62. Now if we will go to IS code, actually, in IS code we have given this clause, that is how to find alpha n. So till value that is of alpha n 0.02, so up to 0.2, we have this value that is actually 1. So if I will draw this diagram, then we have for 0.2 this value is 1, then this value will increase, and that value gives us value 2, where we have this value that is 0.8, and this value we have 0.2. And from this, we are in position to interpolate this, gives us value as 1.7. So now we will substitute these values. We have this formula in IS code, MUX upon MUX1 to the power alpha n, MUY upon MUY1 alpha n less than or equal to 1, then only my column is safe. And then I will substitute values, I will get 0.91, which is less than 1, and therefore safe. So we have ASC required 2% of this. comes 3105 millimeters square. So we will provide 4 bars of 25, 4 bars of 20. I already mentioned I have to see the combination, but this will be 4, 4. So we have equal steel on all faces, same steel on all faces. And from this, I will get value of ASC. So you can see this provided 3220.13, which is greater than 3150. So actually, this is not 3000. This value we have 3150 millimeters square. And then we will go for lateral ties in the same way. So we have 6 mm minimum, and then we have this will be minimum of the 3. So we have to provide 6 mm at 300 mm center to center. And then we have 4 bars that is of 25 and 4 bars of 20. And then we have steel equal on all faces. So likewise, we have to go for these biaxial columns. So now we will stop here only. Thank you.